Welcome back to the course LTE System Overview. We are now still in Chapter 2, LTE Air Interface Principles, but we are now in the last subchapter, 2.5, LTE Physical Channels. So, as you might already know from other mobile radio systems, we always have some logical channels, which are usually in radio link control, processed. They map to transport channels, which then map on physical channels. The physical channels are the ones that are really transported over the air between user equipment and eNodeB, or station if we talk about 2G or 3G. This means that this radio channel is basically transported between user equipment and eNodeB. We either have in frequency division duplex, we have more or less two channels, one for uplink, one for downlink, or we have one that is shared, but at some time points for uplink, at some time points for downlink. We have a certain number of physical channels. We have different channels in downlink and in uplink. For example, in downlink we have the so-called broadcast channel, physical broadcast channel, which broadcasts all the information that is cell related from the station to all the UEs that are in this cell. Then we have the PC fetch, which indicates the format of the control channel. If you remember from the last chapter, the control channel is always localized in the first 1, 2, or 3 symbols of a resource block pair. One resource block was made up of 7 symbols in the time domain. One resource block pair was made up of 14 symbols. The first 1, 2, or 3 of them are not used for data transmission. They are used for the control channel, which means that there the signaling information is transported. And this PC fetch indicates whether this control channel is 1, 2, or 3 symbols in the time domain. The HARC indicator channel indicates at which so-called HARC process we already are at the moment. HARC processes are for error correction on MAC layer. The physical downlink control channel, I already mentioned, is the first 1, 2, or 3 symbols of every resource block pair and carries all the signaling information. So the scheduling information to the UE, the modulation and coding scheme information, things like this. The shared channel is all the rest of the resources without the reference signals that we will see later in this chapter. So of our 2 resource blocks, which make up one resource block pair, we have all the resources that are not used for control channel and not used for reference signals. They are the so-called shared channel, which transports the data from the eNodeB to the UE. In the uplink, we have one additional channel. This is the so-called physical random access channel. So when one UE shows up in a cell for the very first time or is turned on in this cell, it has to do a so-called random access procedure to camp on the cell. This is done in the random access channel. Also here we have shared channel and control channel. So in the physical uplink shared channel, we transport our data. In the uplink control channel, we report acknowledgements, not acknowledgements, channel quality indications, things like this to the eNodeB, so that the eNodeB can then judge whether our channel quality is good enough or not. Here we see a mapping on radio link control, layer 3 on the air, which is usually there for segmentation and reassembling of packets. We have the so-called logical channels, which are then on MAC layer mapped to the transport channels. MAC layer is doing scheduling and priority handling, multiplexing, but also the HARC processes that we already mentioned. So here we have the error correction and we have the mapping to the physical channels, which are then transported over the air. Here we see our physical channels again, the random access channel, the uplink control channel to the station, the uplink shared channel to the station, and the downlink control and shared channel from the station to our UE. So if we think about a UE that is coming up newly in a cell, for example, we turn it on, then it will first of all read the information that is transported in the physical broadcast channel, which is part of the physical downlink shared channel. So whenever all this information is read, we can, or our UE can do the random access procedure, which is then done in the random access channel, physical random access channel. Here, the UE sends a random access preamble and gets an answer, or if it doesn't get an answer, the UE will send it with a slightly higher power until it gets an answer from the station. Then, when we are registered in the cell, we can either send data to the station, or the eNodeB might have data for our UE. And this means that in the uplink control channel or downlink control channel, a scheduling must be requested or must be scheduled. This means that then the eNodeB tells us there is data for you, please check this and that resource block, and then we can download our data. From our channel quality indication in the uplink control channel, the eNodeB will do some corrections, for example, to the modulation coding scheme, things like this, and might also schedule more or less resources for us. But this is just a schematic figure, so it might also be in another order, so that we have first uplink, then downlink, and so on. And then we might go into idle mode, come up again, but we do not need a random access procedure anymore. Now, I was already talking about the so-called reference signals. Reference signals are transported from the eNodeB to the mobile in very specific resource elements. So it is defined which resource elements are carrying those reference signals. The UE will measure them, and from this measurement, it will report a so-called channel quality indication to the eNodeB. From this channel quality indication, or from the RSRP and RSRQ that is calculated from these reference signals, the eNodeB knows how to schedule this UE. There are also uplink reference signals, which means that the UE sends reference signals to the eNodeB for time synchronization, for example. The eNodeB can be made up of 1, 2, or even 4 antennas, because in LTE we have the so-called MIMO enabled. This means that we might have 1 or 2 or even 4 antennas where we send data to our UE. Every antenna has to send reference signals, of course, because it might be that from one antenna the reference signal gets much stronger to our UE, and then the eNodeB would have to reschedule and use the worse antenna a little bit less. This means that with 3 and 4 antennas, already a larger part of our shared channel is used for reference signals. So this means that the 3rd and the 4th antenna gets less resource elements for the reference signals. To summarize Chapter 2, you have learned that LTE uses OFDM-A, and you now know why it is called OFDM-A and not only OFDM, for division multiplexing, and time division duplex or frequency division duplex as duplex method. This depends on the band and on the hardware. Then you learned that there are 2 different cyclic prefixes, one normal one and one extended one, and this has direct influence on how many symbols can be transmitted over the air. And we learned about reference signals, which are used for the estimation of the channel quality. This was Chapter 2, Air Interface Principles of LTE. Thank you for watching.